In this next learning segment, we're going to be learning about exponential functions. And in order to be able to work with exponential functions, we need to know our rules of exponents first. So we're going to start with zero and negative exponents. So some of these laws of exponents are going to be very, very important in all of our future algebra classes. So it's important for us to know that we have a base raised to an exponent. A base raised to an exponent. And that exponent tells us how many times we are going to multiply the base times itself. So it tells us how many times we multiply the base times itself. So exponents are repeated multiplication. Repeated multiplication. For instance, if I have 5 times 5 times 5, that says my base is 5, and I'm going to multiply it by itself 3 times. If I have negative 5 times negative 5 times negative 5, that means I have negative 5 as the base multiplied by itself 3 times. If I have negative 5 times 5 times 5, the repeated multiplication here is the base of 5. It's just the base of 5 times itself with a negative out front. So hopefully you can see the difference, most especially between when we have a base of negative 5 versus a base of positive 5 whose result is going to end up being negative. Now for every non-zero a, so for every base that is not 0, so a cannot equal 0, if you take a number and raise it to the 0 power, that is equal to 1. So 4 to the 0 power is 1. So any integer raised to the 0 power is 1. Negative 5 is also an integer. And if we take negative 5 and raise it to the 0 power, we get 1. 2.35, we can take a decimal and raise it to the 0 power, we get 1. I'm not sure what I just said back there. I think I said negative 5 raised to the 0 power is 5, but it's 1. Anything raised to the 0 power is 1. 1/2 raised to the 0 power is 1. So any number raised to the 0 power, even if I have x raised to the 0 power, as long as x is not 0, it is also equal to 1. If I have 5 plus 7 raised to the 0 power, that is also 1. If I have negative 5 raised to the 0 power, 5 raised to the 0 power is 1, but this negative remains because it is not part of the exponent. That's an important concept for you to make sure you understand. So make sure, this is very important, make sure you understand that. That's a very common mistake to make. So here we have simplify x to the 0. So go ahead and try that. And what did you get? Hopefully you got a 1 and you boxed it. Okay, let's do another example or try. We're going to simplify negative 6 to the 0 power versus negative 6 to the 0 power. So can you tell the difference? If so, give it a try and then come back and see if you've got the answer. Or maybe you have already got it in your head and you're saying, you know what, I know what this is because the base is 6. So the base is 6. The base raised to the 0 power is 1, and then this negative is left behind. And hopefully you're saying here the base is negative 6, and that base raised to the 0 power is 1, and there's no negative left behind. That's our 0 power. Now let's talk about negative exponents. For every non-zero a, once again, a cannot equal 0. So your base cannot be 0. If we take a and raise it to a negative exponent, I can make that exponent positive by bringing the base and the exponent down to the denominator. Changing the position in the fraction. So right now, a to the negative n is in the numerator. By changing its position to the denominator, it makes the exponent positive. Here's an example. 3 to the negative 2 power is the same as 1 over 3 squared. Negative 7 to the negative 4 power. Negative 7 is the base. It is not going to change its sign. It is only the exponent that changes its sign. So if I have negative 5 raised to the negative 3 power, that's the same thing as negative 5 to the negative 3 power over 1. I'm going to move the base to the denominator. The base remains the same, but the exponent becomes positive. And then the numerator, we just have a 1 that's left behind. So it becomes 1 over negative 5 to the positive 3 power. So let's do a few of those examples. Let's simplify 2 to the negative 3. 2 to the negative 3. The first thing we do is make the exponent positive. So you make the exponent positive. So this is going to become 2 to the negative 3 becomes 1 over 2 to the third power. 2 to the third power is on our exponent quiz. Super important that you know your exponents. So the exponents that we need to know are 1 squared all the way down to 25 squared, 1 cubed all the way down to 10 cubed, 1 to the 4th all the way to 5 to the 4th, and 1 to the 5th all the way to 4 to the 5th. If it is on that exponent quiz, you should have all of those exponents memorized. Those values, for instance, 21 squared, you should be able to say 441. 2 to the 4th power, you should be able to say 16. Those have to be memorized so that you can very easily, without a calculator, say the answer to this is 1 over 8. Okay, let's simplify some with some variables. 3x to the negative 5 times y squared. The first thing I do is I highlight all of my factors. So I have a constant coefficient, I have a variable factor with a base of x, and a variable factor with a base of y. So I could look at this and say, well, my base is 3, and that's 3 to the first power. My base is x raised to the negative 5 power, and my base is y raised to the second power. I'm going to rewrite this with positive exponents. 3 to the first, that's already a positive exponent, so it's going to stay where it's at. X to the negative 5, that's a negative exponent, so that base needs to go to the denominator, so its exponent can become positive. Y squared, that's a positive exponent, that stays in the numerator. So our answer is 3y squared over x to the 5th. 3y squared over x to the 5th. So you're going to hear me say something like this. So given this problem, I might not even put the 1 there. I'm going to say, does 3 stay or go? Now, if I'm not sure, I might put the 1 there so that I can see that it's a positive exponent. Well, the positive exponent stays. Then I'm going to say, does x stay or go? When I say it goes, that means it goes to the other position in the fraction to become a positive exponent. So it's in the numerator now. It's going to move down to the denominator to become a positive exponent. And then I'm going to say, does y stay or go? Y has a positive exponent, so it can stay exactly where it is. And then, of course, we rewrite this 3y squared over x to the 5th. But that's the language that I'm going to say. Does it stay or does it go? Does it stay or does it go? Okay. Go ahead and try to simplify these two problems, and we will come back and go over them. So make sure that you press pause so that you have an opportunity to do these problems on your own. Okay, welcome back. We've got 11 x to the negative 5. 11 is a base raised to the first power. X is a base raised to the negative 5 power. 11 stays in the numerator, but x has to move to the denominator to become a positive exponent of 5. Okay, this next one I would need 3 colored highlighters. Now, the negative 7, I can raise it to the first power like that. And I'm going to talk about that in a second. I can even, because the negative is not attached to the exponent, I can even use a 4th colored highlighter. The negative is going to stay. 7 is raised to the first power. It stays. X to the negative 4, it needs to go to the denominator so that its exponent can become positive. And y squared can stay in the numerator. So our answer is negative 7y squared over x to the 4th. Remember, it's negative exponents that move their position in the fraction to become positive, not negative numbers. Please do not confuse something like negative 3 being equal to positive 1/3. That is completely false, not true. Now, you've heard me saying that the base changes its position in the fraction to make its exponent positive. So when we have 1 over y to the negative 4, 1 is a base raised to the first power, and y is a base raised to the negative 4 power. 1 has a positive exponent. It can stay in the numerator. Y has to change its position, so it needs to move to the numerator so its exponent can become positive. And then what's left in the denominator? A 1. So that's the same thing as y to the 4th. So a new rule that we can write down is that if you have 1 over a to the negative n power, remember that a cannot equal 0, then that's the same thing as a to the n power. I love this example because I get to use 4 colored highlighters. I have a 3, I have an a squared, I have a 2, and I have a c to the negative 2. Now 3 is a base raised to the first power, a is raised to the positive second power, 2 is raised to the first power, and c is raised to the negative 2 power. So this is where I say, does it stay or does it go? 3 to the first power stays in the numerator. A to the second power, well, that's a positive exponent, that stays. 2 to the first power, that stays in the denominator. And c to the negative 2, that c is raised to a negative exponent, so c goes to the numerator, and its exponent becomes positive. So our answer is 3a squared c squared all over 2. Okay, let's see if you can try these two problems. 2 over a to the negative 3 and n to the negative 5th over p squared. Okay, welcome back. Hopefully you've tried this on your own and you got 2a to the 3rd power. And on this one, you got 1 over, I always alphabetize. So I believe it goes A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So n comes first. N to the 5th over p squared. That was delightful listening to me recite the alphabet. I hope. And hopefully you're feeling pretty confident about these exponents, zero exponents and negative exponents. Now this is where it might get a little tricky. We're going to evaluate expressions with negative exponents. So first we're going to substitute values for variables and simplify the expression to one value. That's what evaluate means. It means substitute values for variables and then simplify that to one numerical value. Now before evaluating with negative exponents, simplify so that you have positive exponents only. So make sure you simplify so you have positive exponents only first. So we'll write that step down. First step, write with positive exponents. So we want to evaluate n to the negative 3 times w to the 0 power. Well, I'm going to simplify that. N to the negative 3 has to move down to the denominator to become n cubed. W to the 0 stays in the numerator. But remember, anything to the 0 power is 1. So now that simplifies to be 1 over n cubed. Now, in place of n, we can put negative 2. So I'm going to substitute instead of an n, I'm going to put parentheses in its place, raise it to the 3rd power, and I'm going to put negative 2 inside those parentheses. So parentheses in place of n, and then what do we substitute in? We substitute in a negative 2. Well, what's negative 2 times itself 3 times? Negative 2 times negative 2 times negative 2 is a negative 8. So we get 1 raised to the negative 8 power. Okay, let's try another one. Evaluate 1 over n w to the negative 2. Go ahead and see if you can try this one on your own, and we'll check your answer versus my answer. And then I'm going to do just 2 more tries for you. Make sure you've got it, and we'll be done. Okay, welcome back. If you simplified this to be w squared over n, you did well. Then if you put parentheses in place of the w to the 2nd power and parentheses in place of the n, you did really well. And then in place of the w, we're going to put a 5. And in place of the n, we're going to put negative 2. So we have 25 over negative 2. And we always write our fractions in handwriting with the negative moved to the numerator. Not in the middle, not in the denominator, but when we're using our handwriting, we need to put that negative into the numerator. So I believe you have it, but let's just try a couple more. Let's just try -8 x cubed y to the -4 z to the -1 and see if you can simplify that expression with positive exponents only. Positive exponents only. And when you're ready to check your answer, come on back. Okay, I'm going to use 4 colored highlighters, actually maybe 5. I've got the negative, and then I've got an 8 to the first power. I've got x to the third power. I've got y to the -4th power, and then I do need another colored highlighter. Let's see. I think there's highlighters right there. Let's use pink. There we go. That's actually a nice, I should put that in my favorites. That's a good one. So negative stays because it's not an exponent. 8 to the first power stays because it's a positive exponent. X cubed stays because 3 is already positive, and that's an exponent. Y to the -4, that needs to move to the denominator to make 4 positive, and z needs to be moved to the denominator to make its -1, positive 1. Now notice how I make my z's with a little line through them. That is something that I'm going to ask you to do as well, so that your 2's don't confuse me between 2's and z's. So everybody writes their 2's a little bit differently. But if we all write our z's with a line through it, then I won't be confused and I won't mark your answer incorrect. So our answer is -8 x cubed over y to the 4th times z. We take away that exponent of 1 because it's not necessary in our final answer. Let's try one more, and if you can get this one, you really, really, really know that you've got it and that you're ready to get some practice with the homework. Okay, -4 x to the -2 y to the -3 all over z to the -5. Make sure you press pause. If you're joining me back again, welcome back. If you haven't left yet, make sure you press pause and try this one on your own. Okay, I'm going to highlight again. Negative is a negative number, so I'm going to highlight that. 4 is raised to the first power. X is raised to the -2 power. Y is raised to the -3 power. And z is raised to the -5 power. So our negative number, our negative stays in the numerator. 4 to the first stays because the first power is a positive. X to the -2 needed to be moved down to the denominator. Y to the -3 needed to be moved down to the denominator and become +3. And z to the -5 needed to change its position. It went to the numerator to become a +5 for the exponent. So our answer is -4 z to the 5th times x squared y cubed in the denominator, divided by x squared y cubed in the denominator. Don't know if I said times or divided by, but it's definitely divided by. And that concludes this video. In the next coming up videos, we are going to, I'm just going to give you a little preview, we're going to multiply powers with the same base. We're going to learn the power to a power rule and simplify more expressions. And you can see how much fun that's going to be right there. Look at that. We're going to be doing some of that, and you're going to be a pro at it. And we're going to divide powers with the same base. So we're going to be doing some division problems. So those are all the types of problems that we're going to be doing in a future video. But for now, it's really important for you to get that practice so that you are a master at the basics with 0 exponents and negative exponents, so that when we move on to all those other rules, you've got a very strong foundation.